Okay, in this video I'm going to talk to you about the parameter changes, or another way to say that is translations of quadratics. So in order to do this, we need to look back at linear. In our linear family, we saw that we have the equation slope-intercept form, which is y equals mx plus b. When we looked at parameter changes for linear functions, we knew that the m changed the direction and the steepness of my graph. If m is negative, my graph goes down. If it's positive, it goes up, looking at it from left to right. If m is a big number, my mountain gets much steeper, so it's a very steep line. If my m is a small number or closer it gets to 0, the flatter it gets. So a fraction is going to be a lot flatter. So a number less than 1 is going to be flatter. Also, we looked at our b, which changes, it's just called the y-intercept. B changes the starting point on the graph on the y-axis. It's your starting point on the y-axis. So the cool thing about quadratics is that it's just the same as linear. The changes that happen here are the exact same, except we use a and c to describe them, whereas we used m and b in linear. A is just like m, meaning it's the number that's in front of the x term. In quadratics, it's in front of the x squared term, and in linear, it's in front of the x. So it's our coefficient. So a is going to be just like m. A changes the direction, and it changes the steepness. So that's the exact same rules. Okay, the only thing that's different is that we have a quadratic, and so that our up and down are going to mean different things instead of with a line. So if a is a positive number, just like with m when it was positive, our quadratic is going to go up. Except up means it faces up. Okay, that's what up looks like. If it's negative, it's going to go down. It flips. Okay, it's like a reflection. So we look down. That's what up and down look like for quadratics. Okay, now that you always look at the number in front of x squared and see if it's positive or negative first to determine the direction your parabola is going to go. Then we look to see, is it a big number, is it greater than 1, or is it less than 1, is it a fraction? If it's greater than 1, just like for linear, if it was greater than 1 over here, it got a lot steeper. Well, I think of it a little different with quadratics. I think of me having like a book or some sort of thing, pushing down, putting pressure on my parabola, either direction, putting pressure. The bigger that number gets, the more pressure it pushes in on that parabola, and so my parabola is going to get skinnier. The smaller that number is, the less pressure, so my parabola is going to actually get fatter. And so that's how I like to think of it. So, let me move this over a little bit. So, if I had an equation that said y equals 4x squared, okay, I look at a, the number that's in front of x squared, I notice that it's positive, so I know my graph is going to go up. Then I look to see, is it a bigger number than 1 or is it less than 1? Well, it's bigger. So in my mind, I think of it as having a lot more pressure on my parabola. So it's really pushing it in. So that means it's going to be skinnier. So I would really make it a lot skinnier. What if I had y equals negative 4x squared? It'd be the same thing, but instead of opening up, this negative in front of 4 makes it go down. And so again, instead of opening up, I'm going to open down, and again, it has lots of pressure being pushed on those arms of the parabola, and so it's getting skinnier. And so it'd be facing down and skinnier. Okay, let's look at another example. What if I had one that is y equals negative 10x squared? Okay, well, first of all, the negative tells me that it's going to be going down, and then 10 is a really big number, so think of that as putting a lot of pressure on that parabola. What that's going to do is really get it skinny. That's a really big number, it's a lot of pressure, so it's going to be a really skinny parabola, and the reason it's opening down is because of that negative. Okay, let's look at another example. What if I had y equals 1/4 x squared? Okay, first I look to see if it's positive or negative. It is positive, so I know it's going to open up. Then I like to see how much pressure is being put on it. Well, since 1/4 is a really small number, a little bit of pressure is being put on it. So think of the parabola like a spring. If I don't put a lot of pressure on it, it's going to really open up. So now my parabola is going to get wider. Okay, the less pressure, the less it's keeping it together, and so it's going to get wider. Another way you can think of that is the closer that number gets to 0, the closer my parabola gets to 0, and 0 is a flat line, so it's going to really flatten out. Okay, another example, let's do y equals negative 1/2 x squared. Okay, I'm going to look at this parabola. I see that it's negative, so it's going to be opening down. And then 1/2 is a small number. It's less than 1. So again, it's getting closer to 0, or I could think not very much pressure is being put on this spring. And so this would open down, and it would be wider or flatter, however you want to say that. Okay, so that is discussing our A, what it does. Again, positive opens up, negative opens down. If it's a big number greater than 1, it's putting a lot of pressure, so it's getting it skinny. And if it's not a big number or a fraction, it's going to really push out on it, and it's getting wider. Now let's talk about C. This one's really super easy because it's identical to what B does. It's your starting point on the y-axis. So down here I've done an example, okay, of what happens for C. So here if I have my parent function, C is actually 0 because there's no number being added or subtracted here. Okay, I know that it's going to open up because the number in front of x squared is positive 1, so it's just going to open up, just my parent. It starts at my 0 or my origin because C is 0. Let's look at this next example, y equals x squared plus 5. C is positive 5. So whatever C is, that's where I start on my y-axis. So I go start at positive 5, and then I draw my parabola. In this last example, y equals x squared minus 3. Negative 3 is C. That's that constant that's being added or subtracted to x squared. And so that tells me to start at negative 3. Always your starting point's always going to be on the y-axis, not on your x-axis. So let's look at an example. If I did, and now let's get a little bit more challenging. Let's do if I did y equals, do 6x squared plus 2. So for this example, I always look at my A to tell me what direction and how steep, and I look at my C for my starting point. I always start with my starting point. My starting point C is 2, so I'm going to start at positive 2. Now my A is positive, so I know it's going to open up, and then 6 is a big number. It's greater than 1, and so there's a lot of pressure I'm putting on the parabola, and so it's going to get skinny. Okay, let me do another example. Y equals negative 3/8 x squared minus 2. Okay, always start with your starting point, which is your C, which is negative 2. So I'm going to go start at negative 2 this time. Now I go look at my A. My A tells me my direction. So it does not matter that this is negative. That does not tell me the direction. That is only your starting point. A tells you your direction, the number that's in front of x squared. And A is negative, so my graph is going to open down. Now, I also now want to look to see if it's a bigger or greater than 1 or less than 1. And this one is less than 1. It's a fraction. So there's not very much pressure being put on this parabola, so it's a spring opening up. It's getting flat. And so that's how my graph would look. Opening down, flat, and it starts at negative 2. So let's look at how this might be asked on the ESC. What is the result of changing the function y equals 3x squared plus 2 to y equals 5x squared plus 2? The first thing I always want to do is know, is A changing or is C changing? Is the number in front of x squared changing or is my C changing? Well, right now C is 2 on both of those. So my starting point is going to be the exact same thing. So I can go ahead and eliminate answer choice A and answer choice D because we know there's going to be a change because A is changing from 3 to 5. Well, what is that changing? A changes your direction and your steepness. And right now they're both positive, so my direction did not change. But now it says, did the parabola vertically stretch, get narrower, or did it get compressed wider? Well, I'm looking to see, did it get narrower or did it get wider? Well, it went from 3 to 5. That number got bigger. The pressure got bigger, so it really got skinnier. And so that would be answer choice B. If I look at number 10, what is the result of changing the function y equals x squared plus 2 to y equals x squared plus 5? What's changing? My A is not changing. My C is what's changing. So it started at 2, and now it's starting at 5. So it went up 3 units. So I look at my answer choices. A is not what changed, so A and B can be marked out. The parabola is translated down 3 units, or it's translated up. Well, it started at 2, and now it's starting at 5, so it went up, which is D. Number 11, what is the result of changing the function y equals x squared plus 2 to y equals 1/4 x squared plus 2. Again, my c stayed the same, so that did not change. It did not move up or down on my y-axis, but it did go from a 1 as my a to a 1/4. It got smaller, which means that a got smaller, meaning it's less than 1, meaning there's less pressure being put on that parabola, so it's going to get wider. So this one would be a wider parabola. Okay, if I look at 12, what is the result of changing the function y equals 1/3 x squared minus 4 to y equals 1/3 x squared plus 3? Well, I noticed that a did not change. So it is not going to be getting wider or narrower, and my direction is not going to change. What's changing is my c. It changed from a -4 to a 3. So I started at -4, and now I'm starting at 3. So that's going to move up. Well, this one up 4 units, and this one up 3, which is a total of 7 units. So it went up 7 units. I hope this helps you with your parameter changes for quadratics. Just always look at a and c, the number in front of the x squared, and just the constant that's being added or subtracted. A changes your direction and steepness, and c changes your starting point on the y-axis.